Welcome to Spring LIB.
Welcome to problem number 10.22. This is chapter 10, Dynamics of Rotational Motion. We are given a hollow spherical shell which has mass 2 kg and it is rolling down without slipping on a 38-degree inclined plane. So this is 38 degree and this is rolling down without slipping. So the rolling down without slipping and rolling down without slipping condition has A equals to alpha r. The angular acceleration of this rolling equals to the linear acceleration of this moving downward. So we have this mg force which is downward due to gravity, and this mg cos theta which is the normal force. So this is our normal force, and downward force is mg sine theta which is causing the acceleration. The frictional force which is acting on this sphere is, let's say we have F. So we have N equals to mg cos theta and mg sine theta minus frictional force equals to ma. Now since this force is acting downward in this way, so this has a radius capital R, so this will create torque. The torque is R cross F, both are perpendicular R and F, so torque becomes capital R F. Remember, in this situation we have m equals to m here. This is the mass, so don't confuse between small and m, both are same. We will use it later. Now the moment of inertia of hollow sphere is 2 by 3 mr square. So we have torque equals to Rf, which is equals to I alpha. So Rf equals to 2 by 3 mr square alpha. Now alpha is equals to A by R. So we have Rf equals to 2 by 3 mr square A by R. So this R square goes away due to this R. So frictional force is equals to 2 by 3 ma. And we know that the frictional force related with the normal force is equal, so F is equals to mu n, where mu is the static coefficient. We will find the mu later. First we have to find out the acceleration. Using this equation, putting here, so we have mg sine theta minus F equals to ma. F is equals to 2 by 3 ma. M is equals to m, both are same. So we have mg sine theta minus 2 by 3 ma equals to ma. So this gives us mg sine theta equals to 2 by 3 plus 1 ma. M goes away. So acceleration is g sine theta over 5 by 3. So this gives us 3g sine theta over 5. Theta is equals to 38 degree. You can use the calculator to find out the value of the sine theta. So this equals to 3 into 9.8 meter per second square sine 38 degree over 5. So this gives us, after calculation, 3.62 meter per second square. So that's your answer for this part. We have found out the acceleration. Now finding out the frictional force, which is equal to 2 by 3 ma. So F becomes 2 by 3. The mass is 2 kg. So this becomes 2 times 3.62. So this gives us 4.83 Newton. Sorry for this one. So that's the frictional force, and that's your acceleration. Now we need to find out the minimum coefficient of friction. So that means we need to find out the mu value. So mu is equals to frictional force over N, which is equals to 4.83 Newton, which is this value, over mg cos theta, which is equals to 4.83 over 2 times 9.8 cos 38 degree. So we have 4.83 over 15.45 Newton, which is equals to 0.313. So that's the coefficient of friction, or friction coefficient. So this was part A. Now we go to the part B. Now the mass becomes 4 kg. So what the effect on the acceleration due to this change in mass? So acceleration is independent of the mass. So we have A remains same. So the new A remains the same, which is equals to 3.62 meter per second square. Now coming to the frictional force. Now the frictional force is directly proportional to the mass, which is this formula. So this becomes twice. So friction becomes twice. Which is equals to F nu, or the F prime, which is equals to 9.66 Newton. Similarly, we have N, which is mg cos theta. So N also doubles. But mu is independent of m. So mu remains constant, the earlier one, which is 0.313. So that's your answer for this question. Thank you for watching the video.